So we're going to be talking about the future of data and AI on Google Cloud. My name is Sam McVeety. I'm the area tech lead for data analytics at Google Cloud. And like many of you, I've also been doing a lot of work with AI recently. And so we're going to talk about how those different pieces intersect. And there'll be a few different pieces to this talk. We'll look at some of the things that we've just announced and how those build a foundation for our platform, as well as what the future might look like. And that's going to be a little more philosophical. There will be audience participation. There will be a quiz, so pay attention. And so just to get started, let's look at the present. Hopefully, you've been to some of my colleagues' sessions this week. So maybe this is a little bit of review, but just talking about some of the things that we've announced that are going to help to build this foundation for data and AI. So the first thing is BigQuery Studio. And I'm hugely proud of the team for all their work to put this together. It is a notebook-centric experience for working with all of your data and AI in one place, whether you're using Python or SQL, and taking those things and putting them in a place where you're not having to choose, do I want a data workspace or an AI workspace? It's all one unified experience. And we recognize that those disciplines are only going to get closer over time. And so we really view this as a core piece of that offering. Now, speaking of Python, we're also really excited to announce BigQuery data frames. Now, BigQuery has always been very SQL-centric, naturally, as a data warehouse. But we also want to make sure that there's an excellent Python experience. And so with BigQuery data frames, you can now use your favorite open source libraries in Python to write code that then executes directly in BigQuery and use that seamlessly with SQL, mix and match however you want. So that's all surface level. And then if we look a little bit deeper, one of the things that I'm really excited about going toward the future is the support for vector embeddings in BigQuery. And I really like to think about embeddings as sort of a third essential data type, where you have structured data, unstructured data, and embeddings, where you could think about an image where you start with raw image data, unstructured, metadata about that image, structured. Maybe it's automatically extracted, maybe it's manually annotated. And then you have embeddings that are generated for that image, maybe one, maybe many. And what's exciting about these is it really allows you to interact with large language models in all sorts of interesting ways, where they can sort of identify similarities that humans might not see. And so this allows you to do things like search across them. You can use this to identify data for few-shot learning if you're building a prompt around that. And I really think this is sort of the beginning, and that embeddings are really going to be sort of a foundational capability of building this data and AI platform. Another thing we're very excited to announce is this next generation feature store. And so this takes Vertex AI Feature Store and BigQuery and brings the best of them together so that you don't have to move your data between them to take one data set. You can apply governance rules to it, use all the things that you're used to using in BigQuery for running analytics against it, and seamlessly use that for online serving in a low latency fashion as well. And really, this confluence of data and AI is sort of exemplified by Feature Store, having it all in one place using the same tools. And then over on the business intelligence side, I'm really excited to see all the work that the team has put into announcing Duet AI for Looker. And this allows you to do everything from generate charts using natural language to doing those little tweaks to charts saying, this line is too big, it's too small, to then actually generating slide decks and sharing those, interacting with your data using natural language. And I hope that folks caught the presentation from my colleagues Kate and Andrew. If you haven't, I really encourage you to watch the recording. There's a really exciting video about what the future of this would look like, where it's not only collaborating with an AI, but it's collaborating with other people. And so the future of AI and BI looks really exciting. So these are the things that we have so far. And really tying all these together is this idea of DA and AI labs. And this is something that you can sign up for today. We'll have a QR code at the end. And really, this acknowledges the fact that it's an incredibly fast-moving space, and not everything is going to be production quality immediately. And people are excited to go on this journey with us. And so by signing up for this, you can have early access to the experiments that we're running, some of which will work out, some of which won't, and really discover what we can do together with AI. So that's today. Now, let's look at the future. And so in trying to predict what the future of this space might look like, I think it's useful to sort of think about 3 possibilities. So roughly, we're going to call these the asymptote universe, the domain-specific mastery universe, and the singularity. And I'm going to explain what those are, and there will be a quiz, so pay attention. So the first one, the asymptote universe, is really, models get better, but they don't get better very quickly, and the sort of big jump that we just saw in capability from reinforcement learning, from human feedback, we don't see similar jumps to that. We see things, stay at the sort of sub 99% quality level, and there's a lot of engineering to really turn these into useful applications. You have to assume that humans are going to be in the loop pretty much in perpetuity until we have some continuous jump in capability. And so there's just like a lot of engineering to backstop those different issues with model quality. And I think that there's actually really good precedent for this in other disciplines. So like look at self-driving cars, where that has really just, it's been a slog, right? Like you're trying to crank out another percent, another fraction of a percent to get them better. And like it's useful, but it's hard, and it doesn't mean that like all of a sudden it's magic and it works. That's universe 1. Universe 2 is domain-specific mastery. And so this is where actually models do get really good, not at everything, but at specific tasks. And so imagine that for natural language to SQL, for example, really like you get to the point where it's indistinguishable from 100% quality. And so you can actually then assume that you don't need a human in the loop for those subtasks. And this is actually the thing that we're going to focus on the most today, because I think it creates really interesting questions for how do we redesign our systems if we end up in this sort of scenario, because you can then have these discrete boxes that say, you essentially have an API contract of, I'm asking the model to go from natural language to SQL, and it just does it. I don't need to check that with a human. I can treat it like a bit of code that does that deterministically. The last possible universe, singularity, not going to talk too much about this. Basically, AI takes all our jobs, and you're back to this magic box of like it can do anything, and so not a whole lot useful to speculate there. So while we're going to focus on universe 2, I would love to get a quick poll of the audience. In the next 5 years, do you think that we're going to be in universe 1? Raise your hand. Universe 2? And universe 3. All right, I think the 2s have it. That was great participation. Thank you. One of my colleagues was saying you're going to get 10 hands at most. So 9 a.m. crowd, you are killing it. Thank you very much. Yes, it was a leading question. Fair. So in talking about what this looks like for universe 2, I think it's really helpful to look at what does our mental model for interacting with large language models and in future advancements look like. And so where we started, I think for a lot of people, is sort of this magic box of like it can do anything. And I don't know about you, I have been in many, many conversations where that is the starting point. If someone says like, I got the language model to do this thing, like let's ship it, it's amazing. And so you sort of have to like walk that back and say like, oh, maybe, it's very cool, I appreciate your enthusiasm. And so, that enthusiasm is great, but I think where the challenge is it prevents us from thinking critically about, yeah, models are really good at some things and then they're not good at other things. And so, how do we actually create a taxonomy around that thinking to then say, if we're designing a system, if we have a block diagram of boxes and arrows, where does a model make sense and where doesn't it? And if it's just like one box that is the machine learning model and like magic happens, that's not super useful or rigorous. So, moving to something that is more defined. And one way to do that is to think about lenses. And so this is really, lenses, roles, thinking about things that models are good at. And so then how can you sort of fit these in different slots where you've got, maybe a standard system in one place that's talking to a model in another context, and then you're chaining these different things together. And so beginning with the translator, we've seen that models are really good at this. Like they're good at looking at patterns and then translating not only between sort of languages, whether that's human languages or machine languages to humans and vice versa, but you can also look at how these can translate from intent to action and things like that. They're also really good at summarizing. And so there are a number of cases where you want to take a lot of information and collapse it into something smaller. There's some fun interactions with embeddings around this as well. And then they seem to be, there's interesting use cases around personalization, where you can think about, again, sort of taking intent to action. So like, let's say that I sort of have a sidecar model that I'm using for my BI tasks, and it's looking and saying like, wow, Sam, you look at revenue graphs a lot. And so it uses that to infer like, this is something you care about, and it starts to build an idea of what are the attributes that I'm looking for when I want a custom built report. So you can use this is one approach to sort of look at what are models good at, what are they not. Another one is sort of applying system 1, system 2 thinking. So this is getting into psychology a little bit. Are folks, anybody familiar with system 1, system 2 thinking? Yes, great, from Daniel Kahneman. And so system 1 thinking is this sort of fast, abstract, as in abstract art, like making fuzzy connections of like, somebody asks you a question, what is your instinctive answer to that question? And it seems like this really matches how models behave in a lot of ways. Like they sort of infer a bunch of patterns, whether those patterns are robustly grounded or not, and they say, yeah, here's my answer. Whereas system 2 thinking is really much more analytical and structured, and tends to look a lot like programming languages. And we don't see models being as good at this. You sort of see, like, if you give a model a math problem, for example, it tries to sort of pattern match it and say, like, I know there's some numbers, there's some operators, this is a plausible way to give you an answer, but it's not applying rules to say, should I add these things together? How do I check my work? It doesn't understand the significance of a decimal point, and so it sort of puts it in there somewhere because it has seen there needs to be a decimal point, but it doesn't understand the sort of semantic import of that. And so then you actually combine these in a plugin architecture. And this is the way that we're seeing how to bring those two together in a way that's productive, where the model sort of handles the system 1 thinking, and then you hand this off to sort of a system 2 plugin, like an analytical engine, like just running a little Python function inline that is handling that for you. So these are a few different ways to think about what these model capabilities could look like in this sort of domain-specific mastery universe. And so let's assume wild success, that like we get to 100% at a lot of these different subtasks. What would that look like? What still matters? Because now you can suddenly assume that you have these subsystems that you don't have to program them anymore. And how does that change your overall system architecture? Well, you still need engines to actually run stuff. And being a data analytics person, I'm heavily biased, but I think this is actually a really important thing to think about in terms of like critical path, where usually if you're writing a query, for example, you're spending a lot of time composing the query and taking your human intent and translating that to SQL or Python, and then maybe debugging it. And then the actual time to run that on the engine is sometimes a really small fraction of that. Whereas if we think about a possible future where I can take natural language and turn that into an executable query very quickly, all of a sudden, like, the time bound is actually coming from the engine. And so you get to this point where if you want to sort of have this language model-centric future, you have to think about, what does it look like to have engines much more on the critical path of, if you're iterating through different approaches. And then I think like a key piece of this is making sure that the architectures you're working with are serverless so they can sort of scale up and be responsive. And so the bumper sticker I have not yet created, but I'm going to, is LLMs heart serverless, and feel free to steal that. But I think that there's a really interesting sort of collaboration between language models and serverless here. The second piece is verification. So you have tried to get a model to do something. How do you know that it did the thing that you asked it to do? And the sort of simple answer isn't really satisfying, where you say, well, I asked it to do a thing, and it gave me some SQL, and then I looked at the SQL, and it looked correct. And that's great if you are a SQL expert, and if everybody that also needs to verify the thing is also a SQL expert. And empirically, I have a bunch of colleagues that have said, hey, it generated some SQL, and it looked really good, and then it actually took me half an hour to realize it was wrong, and subtly wrong. And so if we're in this situation where we're depending on models to do this translation for us, how can we actually create languages or constructs that are optimized for verifiability? Because a lot of programming languages, we expect humans to take a lot of time writing them. But if we're in a future where like humans are going to take no time writing something, they're going to spend all their time verifying and checking. What does that change semantically? Like, what do we want to prioritize for how that looks? And so I think there's some interesting open questions around language research that could be here. And then there's access control. And so, I'm not planning to grant a model access to every bit of data in my company without any guardrails. I'm imagining you're probably not going to do that either. And so, how do we think about, is there a middle ground, though, that is better than the status quo? Because if a model only has access to sort of what its human would also have, then you get into these same sort of slow iteration loops of, I need access to that table. Now I have to go ask for access to that table, and I have to wait an hour at best to get approval, and you sort of iterate. And again, you're sort of slowing the model back down to human speed, and slower than human speed, in fact. And so how can you think about, can we change access control models? Can we build in maybe some privacy-centric constructs so that you're actually allowing the model more access initially, but maybe you're controlling the outputs in a more careful way, or you're sort of doing something like that? Data, training and data still matter as well. And so I think that like a key piece of this is data quality is probably going to matter as much, if not more, going forward. I think we've started to see the plateau that you get with general purpose models, and how they're pretty good when you try to apply them to a specific domain. But like, actually having high quality fine-tuning data is really important. And so how do we continue to curate good data sets? How can we make sure we can share them? How do we track lineage? All of this still really matters. And then what I think is exciting that actually turns this into a feedback loop is you can use models to enhance data then too. And so whether you're creating synthetic data sets and maybe reweighting them to create better training data, there's sort of, rather than just data powering AI, you also have AI powering better data. And so I think that's a really exciting part of this future. Then there's communication. And so there was a meme that was going around, maybe folks have seen something similar, of, I want Bob to attend a meeting. And so my intent is Bob attend a meeting. I go to the model writes like a multi-paragraph email that invites Bob to the meeting. Bob uses his model to extract, like, Sam wants you to go to the meeting. We don't really need to round trip through two models to convey that intent. And so like, how does the interaction with language models change how we communicate intent and information to each other? Because if we're using a model to generate a slide deck, and then somebody is using their own language model to condense that slide deck and re-summarize it, it seems like we're wasting our time. Is there actually like a kernel of information that we can extract that is the core of what we want to communicate? And then maybe there are sort of different ways to customize that for different audiences. And then finally, there's ethics. And this really matters because, particularly in the data space, I think there are correlations that can exist in data that may or may not be grounded in reality. And going back to how models really like to find patterns, whether those patterns should or shouldn't exist. And so I think we have to think really critically about what data are we providing to models. Are we thinking about selectively reweighting it if the training set that we had was biased in a certain way? How do we reweight that? And my own personal experience with this was the bio that many of you read for Cloud Next. I fed in some bullets, Sam does these things, he does these things. And it was actually a really, really good bio that came out from the chatbot that I was using, except for two things. So it gave me 2 dogs, and it was very cute, and maybe that's in my future. It also gave me a wife, and my husband wasn't really very excited about that. And so if we're thinking about like using models for data imputation, I think we have to be really careful of saying, hey, there's this blank field in the Sam row, what should we put there? And if we're not careful, I think you create a lot of sort of dangerous correlations. And so we have to be really careful here. So if these are the things that we still matter in this sort of domain-specific master universe, how do we try and navigate that? And so talking about how Google is approaching this, how I would imagine many of your companies are approaching this, is sort of plotting this course that really prioritizes modularity. And so we think about how do we make sure we have the best infrastructure to build all this stuff on? How do we have great applications for people to use this in a first-party way? And then also, how do we partner? Because I think that there's so much innovation happening here. It's pretty unrealistic to think that that's all going to happen at one place. So how do you plan to slot in different pieces where relevant? And so one of the things we've been prioritizing right now, and this goes back to those slides at the beginning, is really how do we make the best infrastructure for a language model-centric future? And it's things like vector storage and embeddings and things like that, because we think that these are going to be at the heart of so many workloads. And they are fundamentally hard problems. They're not going away. And so if we can solve these at scale and make sure that there's sort of off-the-shelf solutions for using them, that's going to be great for everyone. And we don't want to stop there. We want to make sure that we're using models to really provide an amazing first-party experience as well. And so you think about the work that's happening in BI Duet, for example, and looking at how do we take the ways that developers and analysts and different folks are interacting with our platform and take the best of machine learning to make that better. And then finally, how do we partner and how do we make sure there's this modular ecosystem, whether that's people providing UDFs or providing high quality data for people to federate and fine tune on, so that you can really pick your use case and take the different pieces that you want. And think about going back to your system diagram, where does a model make sense? Where doesn't it? And then we're going to have to iterate. This is super fast moving. We have to sort of think about where are we now? Where might we be in 3 months? And so looking at where are we on the improvement curve? And specifically, are we at diminishing returns? And I think this is, whenever there's a ton of exuberance about a new field, there's also a danger of putting a lot of effort into efforts that have diminishing returns. And so if you think about prompt tuning, for example, it's really exciting to get a prompt that works, and then you spent 5 hours doing that, and then get nowhere for the next 5 hours, or realize that if you just move a comma in a weird way, that actually gets you some improvement. And so how do you sort of do a breadth-first search of approaches so you're not going down this one specific path that might really just hit this quality asymptote and you end up wasting a lot of time, and then the model changes and it's all obsolete. And I think we also have to be realistic of, with some of these use cases, if we look at a bunch of different approaches and something nothing is getting us there, maybe we actually are in this asymptote universe, and we have to think about, are there non-machine learning related approaches that we really need to employ, because we're just not going to get there by focusing solely on the model, and we need to build a system around it to make up for those shortcomings. So those are some thoughts on the future. And what we'd really like is for anybody who's interested to sign up for this DA AI Labs. We're going to be iterating quickly. We're going to be releasing a lot of stuff, and I'm really excited to explore the space with you. If you want to do that, QR code is there. I'll leave that up for a little while, see lots of phones out. So yeah, this is going to be early access to some of the innovations that we have. We're going to release this across a number of products, and we're really excited to go on this journey with you. All right, thank you very much. You've been a wonderful audience.